Okay, in this video we are going to break down this unit circle. I included a few other things here. The bottom right corner I have a table to help us memorize these values for sine and cosine and the unit circle. So I might be jumping the gun a little bit down here, but I think it will tie together nicely. So I included that, and then on the right over here I included these special triangles, which I have already covered in a different video, but we're going to incorporate those into this unit circle too. We'll see how all of these things really are intertwined and just various ways of looking at it and memorizing these values, which are critical in this class. Okay. So let's begin with this unit circle I drew. I didn't label X and Y. Let me do that really quick, kind of OCD kicking in here. All right. Okay, so the unit circle just simply means it's a circle with one unit, right? The radius is 1. So no matter where you drew this radius, right, we get 1 right here. So therefore, I know 4 points, right? The 4 that I labeled, and no need to explain those. I added those before I even started the video. First things first, let's talk about degrees and radians. Okay, this video, there's going to be a lot of information. Watch it more than once if you need, pause it if you need to. Okay. Degrees and radians. So we have, like, hopefully kind of just common knowledge, otherwise brush up a little bit on degrees, but hopefully any degree, any angle in degrees I give you, you should be able to, approximate it fairly well. So knowing that a rotation of a full circle is 360 degrees, right? Then I know half of a circle is 180. And then I could kind of break it up from there. So a right angle, again, hopefully before watching this video you knew degree measurement, is 90. I know down here would be 270. Now I'm going to pay extra attention to this first quadrant in much of this video, because then we could just use quadrant 1 to fill in the rest. But this green angle here I drew, we know that that would be a 45-degree angle. Okay. And then because we have this special triangle with a 30 and a 60, right, let's go ahead and fill those in as well. So approximately, I don't know, a third of the way, somewhere around here-ish would be my 30, and then somewhere around here-ish would be 60. Okay. Those angles we need throughout this unit circle. Right, so for instance, like a 45 degree here, right, would be 135 because I went 90 and then another 45. So that's 135. Can we fill in all those 35s? I'm going to break this up just a tad bit more for this next part. Let's do 2 little circles here. Okay. So if we split all these 45s up, right, we have, let's stick with green. We have the 90s and the 180 and then all these 45s. Right, so from 180 to here is 225, and then 270 to here, that would make this 315. All right, and then I wanted to do this one here with all the 30s and 60s. So we know 30 and 60. Okay, so basically we just keep adding 30, right? 30 degrees, 60 degrees, 90, 120, 150, 180, 210, 240, 270, 300, 330. Okay. Now, in this unit circle, all of these, circle with the 45-degree cuts are in there, and the circle with all these 30, don't know how that happened, with all these 30-degree cuts are also in this one big unit circle, right? And that's why it starts to look a little overwhelming here in a minute. Okay. That's degrees. Hopefully that's a review. I probably wasted a couple minutes explaining something you already knew. Radians, though. Okay, we talked about, and it comes directly like from an old geometry formula, might help you memorize it, but that a full circle is 2 pi radians. Remember the circumference of a circle, the formula is 2 pi times the radius? That's because this 2 pi here represents the radians in a full circle. Okay, so all the way around 2 pi. Well, therefore, if that's considered 2 pi, 180 only, right, is 1 pi. So 180 degrees is equivalent to 1 pi radians. And here's where literally you just start kind of breaking it up. If 180 is pi and 90, right, 90 is half of 180, then 90 is pi over 2 because it's 1/2 of pi. And then if I take half of that, I'm here to this 45. So half of a half is a fourth, right? So that's pi over 4. Likewise, I could always compare 180 to these angles here. So 180 divided by 6 is 30, right? So therefore pi over 6 is 30. 180 divided by 3 is 60, so pi over 3 is 60. Here's where, in particular, breaking these circles up, as I did on the right over here, is going to make it a little easier. We counted by 30s and went all the way around, right? Well, 30 is pi over 6. So let's count by pi over 6 and go all the way around. So 1/6 plus 1/6 is 2/6, right? 2 pi over 6, which is pi over 3, which we have here. And then if I add another pi over 6, I'm at 90, which is 3 pi over 6, right? Which is pi over 2. 3 over 6 is 1/2, pi over 2. And you kind of keep making your way all the way around. So there's 3, here's 4 pi. Oh, I'm getting ugly here, I'm sorry. But 4/6 is 2/3, right? So right here, where 120 is 2 pi over 3. Then I need this angle here, which is another pi over 6, so 5 pi over 6. Right? Now I'm gonna only use this big one now. That my small one I use to kind of describe what's happening. I keep adding 30, right? I keep adding pi over 6. But I think from here forward we could stick here with the left one. So 6 over 6 is 1, and there's my 1 pi. If I add another 30, I'm at 7, right? 7 over 6, 7 pi over 6. If I add another 30, I'm at 8 pi over 6, but 8 over 6 reduces to 4 over 3. 4 pi over 3, or 4/3 pi. And then 9 pi over 6, I'm down here, which is 3 pi over 2, or 1.5 pi, right? Because 180 was pi, and then I add another half of a pi, so I'm at 1.5 pi, 3 pi over 2. Okay, keep going, we get 10 pi over 6, but 10 over 6, that reduces to 5 over 3, 5 pi over 3. 11 pi over 6, and then 12 pi over 6, but 12 over 6 is 2, right? Which we said 0 degrees and 2 pi, they're coterminal, same angle, same terminal side. All right, this is probably the harder one. We took care of the hard one first. So let's do the 45. If every 45 is pi over 4, right, then here would be 2 pi over 4. Oh man, that got ugly. 2 pi over 4, which is reduces to pi over 2, which we have, right? And then 3 pi over 4 is here, 3 pi over 4. 4 pi over 4, which is 1 pi. And then 5 pi over 4. Remember, that's the 225 degree angle. 6 pi over 4, but 6 over 4 is 3 over 2. And last, we have 7 pi over 4. Okay. I'm going to cut this video here and just continue with the part 2. It's quite a bit to digest. There's all the angles. I got ahead of myself a little bit. In the next video, I'll continue on with what are we going to do with all these triangles in this down here. Okay, part 1, there's the angles.